All right. Now, way back before, we took a couple of days off for the English 1 end of course and a couple of days off because they kicked us out of the classroom and made me give the English 2 end of course test on Wednesday and Thursday. We had begun working on the quadratic formula. Okay. Um, so it's been about a week since we've gotten to look at that. So I figured it's probably a good idea for us to take a look at a few more problems, remind ourselves how this formula works, what kind of answers we can expect to get from the formula, and so forth. Okay, so we're going to have another look at quadratic formula. I'll work a few problems with you, kind of hopefully get your brain back going in this direction, and then you'll have an assignment for you to practice for these problems. Okay, quadratic formula. Okay, as you probably already know, for those of you that attempted your homework from last Thursday before the 3-day weekend, quadratic formula can be a bit tricky, okay, particularly the way it looks. People tend to freak out by the way the quadratic formula looks. It's very complicated looking, so people automatically assume that means it's going to be hard, and it's not hard, okay? It's just managing a large formula. Okay, so use the quadratic formula to solve, and we have this problem here, okay? Now, first off, we only use the quadratic formula when we have quadratic equations, okay? So how do you know, or how will you know, if you have a quadratic equation? Okay, this equation that's on the board, is it quadratic? Okay, yes it is. Why is it quadratic? Yes, there's an x squared, okay? That's when you're going to end up with parabolas, where you have one variable that's in the first dimension, one variable in the second dimension. Okay, so we've got y to the first, we've got x squared. That's going to bend our graph. We end up with a parabola. That's quadratic, okay? Now, just a couple of things. Of course, the quadratic formula has all those a's and b's and c's in it. We just have to figure out what is a, what is b, what is c, and plug it all in. But the thing that we need to remember first and foremost is that the formula is only going to work for us once we get it into this format. Everything on one side of the equal sign. Okay, and what we said a week ago yesterday was it does not matter if we send everything to the left side of the equal sign or to the right side of the equal sign. Okay, send it all one direction or the other. Basically, empty out one side of the equal sign. Well, when you look at the equation that we have here right now, is everything on one side of the equal sign? Clearly not. Okay, clearly not. Now we can send all the stuff either direction. Okay, which would mean if we're given the choice, we would probably want to try to choose to send everything to the right. Okay, and the reason we might be tempted to send everything to the right is because most everything is already over there anyway. Okay, but I'll tell you this, the higher you go in math, and I mentioned this the other day, the easier problems arise when the highest exponent is positive. Okay, so in this case, our highest exponent is an x squared. Okay, we'll look at our x squared. Is it a positive value right now, or is it a negative value right now, or what? It's negative right now. Okay, I'm telling you, problems can be a little bit easier in the long run if we can make that guy be positive rather than negative. Okay, so instead of just letting it sit over there on the right side where it's already negative, I'm going to bring it to the left because I know that when we switch across the equal sign, it's going to change the sign. Okay, so 3x squareds, the negative 3x squareds, I'm bringing them to the left. Okay, they're already being subtracted, so I'm going to add them. On the left, that'll give us 3x squareds. There's that minus x that was already there. Equal sign will always be there. And now the only thing left on the right is a positive 4. Okay, so we're going to bring the positive 4 over because we want everything on one side of the equal sign. How are you going to move that positive 4? Subtract it. 3x squareds minus x minus 4 equal nothing. Okay, that's what we want. Everything on one side of the equal sign. Once we get to this point, then probably what you want to do is go ahead and maybe even write it down. Identify what A equals, what B equals, and what C equals. Okay, and remember, this is ax squared plus bx plus c equals 0. Okay, that's the format for the equation. So let's see, a equals something, B equals something, C equals something. Okay, well, what's what? Okay, what does A equal? Yep, that's your, okay, A is the coefficient in front of X, so it's a 3. Okay, and I heard somebody say 3x squared. That's fine. I understand what you're thinking, but the A and the B and the C, these are just the coefficients. Okay, nothing to do with the variables. A is simply the number that comes in front of x squared. Okay, so it's a 3. How about B? Okay, B is the number that comes in front of x to the first. What comes in front of x to the first? Yeah, it's a 1, but remember, negatives and positives belong to the value that follows them. So it's not a positive 1, it's a negative 1 that's in there. C, what's C? Negative 4. Okay, if you can get to this point, you've got a real fighting chance of getting the question right, because now all we have to do is plug into the formula. Okay, at this point, what we need to do is we go to our formula chart. We say, hey, I've got a quadratic equation. On my formula chart, I've got a quadratic formula that will tell me exactly what these answers should be. So we go to our formula chart, we get our formula. And the formula says x equals negative b plus or minus square root of b squared minus 4ac, all divided by 2a. Okay. Well, one more thing I want to point out to you, and we talked about this last week as well, is that plus or minus guy that's in the numerator. Okay, what does that symbol mean? Plus or minus, sitting right there. Yeah, both of them. It's actually, this formula is kind of like a condensed version. This one formula is going to give us 2 different answers. So we're going to work this fraction both by saying negative b minus the square root of b squared minus 4ac divided by 2a, and by saying negative b plus the square root of b squared minus 4ac all divided by 2a. Okay, but for starters, let's just get our numbers plugged in here. X equals, okay, well, let's see what we got here. The formula has a negative, okay, and that's, I've told you before, that's one of the things that Algebra 1 students botch more than anything else with this formula, is we lose the negative that's built into the formula. Don't lose that guy, okay? But what's B? Negative 1, plug it in there. Okay, so we got a double negative. We'll have to deal with that here in a few minutes. Okay, right now I'm not worried about anything else except for just plugging in to what the formula says. Okay, formula asks for b again, negative 1. Formula tells us to square that and then subtract away from that. 4 is built into the formula. What's a? 3. And negative 4. That's really why I like you to write down what A equals and B equals and C equals, because it really turns this part of the problem into nothing but a connect the dot puzzle, where all we have to do is just plug in the numbers that we've already written down. Shouldn't be any real mistakes plugging into the formula. Okay. All right, now before we go to the calculator, and some of you learned this lesson the other day a little bit the hard way. Some of you tried to go from this spot to the calculator and type all this stuff up. And the problem is there's just way too many algebraic places where you can make a simple mistake typing this thing up. Okay, so we probably need to simplify as much as we can before turning to the calculator. Okay, so right off the bat, in the numerator, we got the negative of negative 1. What happens when you get a double negative? It becomes positive, so that's positive 1. Plus or minus, we're going to let that thing stand here for a few minutes. Let's see what's going on in this numerator. Okay, we've got negative 1 squared. Okay, second period had big problems figuring out what negative 1 squared is. Let's hope we all can do a little better. What's negative 1 squared? Positive 1. We had like 19 incorrect answers before we finally figured out that negative 1 times negative 1 was positive 1. Okay, let's see what else we've got going on down there. I'm going to leave this minus sign underneath the radical and leave it there for a minute and figure out what this big number coming at the tail end of that radical is. Okay, 4 times 3, 12. Okay, 12 times 4 is 48. Positive 12, negative 4, negative 48. okay? And we'll deal with this double negative here in a moment. In the denominator, we got 2 times 3, which is obviously 6. Okay, 1 plus or minus. What's underneath the radical? 1 minus negative 48. What's the double negative do? Positive. So this is 1 plus 48, 49. Okay. Now this one's actually going to work out fairly nicely. Sometimes the quadratic equation does this. Okay. What do you know about the square root of 49? It is 7. Okay. The radical actually cleaned up nicely because we ended up with a perfect square underneath the radical. It's cool when that happens, but it doesn't often happen. Okay. But anyway, here we go. Now we're down to the point where we would either turn to the calculator, which I would probably argue in this case you don't even need to turn to the calculator. The calculator would probably be more of an issue if the radical wouldn't go away. But here we have a situation. We've got x equals 1 minus 7 over 6, and x also equals 1 plus 7 over 6. So now I'm kind of breaking the problem into the two parts. We said quadratic formula is going to bring us two possible answers. Okay, one from the positive side of that numerator, one from the negative side of that numerator. So I'm breaking it into two parts. Worry about them separately. Okay, what's this numerator on the left here? 1 minus 7. Negative 6. Second period had a problem with that too. Okay, and negative 6 over positive 6? Negative 1. Okay, that's nice. Got a nice, neat whole number. Okay, and quadratic formula doesn't do that very often, but there it is. What about this numerator? 1 plus 7, 8 over 6. Okay, and 6 goes into 8 one time with a remainder of 2. 2 over 6 reduces to 1/3. Okay, so our graph crosses the x-axis 2 times, once at -1, once at 1 1/3, and those are our solutions. -1, positive 1 1/3. We use the curly braces because that is not an ordered pair. That's not an x comma y. That's two different locations on the x-axis. So we use the curly braces to show that it's a set, and these are the two answers that fit the set. Okay, so there it goes. That's the way the quadratic formula works. Okay, now it's not always that nice. Okay, we saw on last Thursday that sometimes we can get some fairly ugly numbers out of the formula. So let's look at one that's going to be a little less kind to us. Okay, now the first thing we said we have to do is we have to organize the problem so that we can plug it into the quadratic formula. Okay, we'll have a look at this problem. Okay, first off, is it quadratic? It is. Okay, we got an x squared in there. So it is quadratic. It's going to graph a parabola, so quadratic formula is an option. Okay. Now, do you have to organize this one? No, everything is already on one side of the equal sign. It would be nice if they hand us a problem like this already. Okay, so we don't have to organize it. It's all good. Let's identify our values. A equals, B equals, C equals. What's A? 3 this time. B, 2, and C this time, 5. Okay, they didn't even give us any negatives. That's nice too. Okay. Let's get the formula off of the formula chart. Formula says x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now let's plug it in. See what we got. Negative, what is b? 2 plus or minus square root of 2. Formula says to square that, then take away 4 times a, which is 3, c, which is 5, and the formula says that the denominator has a 2 in it, which is multiplied by your a value, which is 3. Okay, doing nothing more than just plugging in numbers at this point. Now let's clean this thing up and see what the answer is going to try to look like. X equals negative of 2 is negative 2 plus or minus square root. Okay, 2 squared is 4 minus 4 times 3 is 12 times 5 60, exactly. And 2 times 3, we got a 6 in the denominator again. Okay, that's just a coincidence. It's not like the denominator is always going to try to be a 6 or anything. Okay, so let's see what else we've got. -2 plus or minus. What's underneath the radical? 4 take away 60. Yeah, -56. Okay. Now we talked about this situation a little bit. Well, not a little bit. We talked about it a lot actually on Thursday before all the testing began. Okay, we got a negative that's trapped underneath a radical. Okay, we don't like this. Okay, and the reason we don't like this is because there is no number that satisfies this situation. Okay, you cannot take the square root of a negative number. Okay, because a positive times a positive is always positive, a negative times a negative is always positive. There shouldn't be a negative underneath there, but there is. Okay, now you remember what we called this? Say it again. I think imaginary, exactly. Okay, what this condition happens is, okay, and we said it the other day, when we look at parabolas, we expect solutions to exist on the x-axis. When we look at parabolas, we expect solutions to exist on the x-axis. Okay, but we also said, you know what? There are situations where the parabola might not cross the x-axis, yet there might still be some values that make the problem work. We don't understand this. Okay, this is kind of beyond our mathematical understanding. We believe that solutions ought to be on the x-axis. That's what our understanding tells us. So we can't understand what happens or what is going on when you end up with points that are not on the x-axis that actually work. Okay, so like we said, sometimes when we don't understand things, we actually name them until they get figured out. And right now, it's still not figured out. We call them imaginary numbers. Okay, this negative sitting underneath that radical is going to cause imaginary numbers. We're going to get some numbers that work for x, but they're not on the x-axis like they should be. Okay, now here's where we go to our calculator. We have a radical that is not going to simplify itself. Square root of 56 is not a nice, neat whole number for us. Okay, so we're going to be in our calculator figuring out what the decimal point is. The problem is the calculator does not understand any more about negatives underneath radicals than we do. So the one thing I told you is to make sure your calculator is in the proper mode. Okay, the calculator can be programmed to basically not deal with it, but for lack of a better word, almost ignore the negative that's underneath there. And the way that we do it is typically in your calculator's default position in the mode down here, this real word is highlighted, okay, which means it's going to look for solutions on the x-axis. We need to tell the calculator that, hey, you're going to get a solution, but it's not on the x-axis. And we do that by coming down here and moving that highlight off of the word real and putting it on a plus bi. Okay, a plus bi, that's actually what we call a complex number, and you'll work with complex numbers more when you get to Algebra 2. Okay, but anyway, once you have your calculator there, okay, on that a plus bi, then you can actually get the calculator to answer this issue with the negative underneath the radical. So I'm entering in my numerator here. I've got -2 minus the square root of -56. I'm going to close that parenthesis. That's my entire numerator, and my entire numerator is then divided by 6. Okay. Now, when you press enter, you're not going to get what you would typically think of as a nice, neat number. It's going to give you a complex number. Okay. Well, let's write this thing down. Now you see the little arrow. It's off the side of the screen. We're going to have to go over there and get some information here in a second. But for starters, here we have this value, -0.333333. What is 0.3 repeating? What is that mess? It's 1/3. Okay, it is 1/3. This says -1/3 minus, okay, well, minus what? I don't know. It's off the side of the screen. Go get it. Okay, we have a decimal point. There's that I. for imaginary. Remember on the mode we said a plus bi. Okay, when that I shows up, that's indicating to us we have an imaginary number. Okay, so let's just get part of this decimal point and put the I, 1.25 I. This is a complex number, a plus bi. And again, you'll learn more about that in Algebra 2. Right now, we're just kind of accepting the fact that it exists. You'll learn more about it later. Okay, that's one of our answers. Okay, this is a value for x. We've got the negative 2 minus the square root of negative 56 divided by 6. Now we also need negative 2 plus the square root of negative 56 divided by 6. So I'm going to go second entry, which will pull up that equation that I just typed a moment ago. And I'm going to scroll back here, and all I'm going to do is change that subtraction sign to a plus sign. If you want to type it all the way over again, go right ahead. Okay. Once again, what is this negative 0.333333? Yep, negative 1/3 plus this time. And I bet the decimal point is the same down there. We'll check it anyway. Yep, 1.25 I. Okay, these are your values for x. Okay. What that means is when you see numbers like that, it means here are the solutions, and they're not on the x-axis the way they're supposed to be. That's all that means. Okay, that's all that means. So if you ever bump into one, I don't think you'll run into anything like that on the end of course test. Okay, but we are going to talk about this situation a little bit more in the coming days, but I don't think they're ever going to give an Algebra 1 student a parabola or a quadratic that does not have real solutions. Okay. There's how it is when if you have to deal with it. Let's look at one more, and I'll leave you alone with it. Is this equation quadratic? How do you know? Yep, it is quadratic because it has a square. Can we work with the equation the way it is, or we have to mess around with it before we start? Yeah, we're going to have to rearrange this equation. Okay, we have to send everything to the left or send everything to the right. Which direction do you think we want to go? You want to go left, go right, what? Go left? Okay, you can go either way. It's all good. It'll all work out. Okay. Personally, I want to go right. Why do you think I want to go right? Okay. I really, really, really want my highest exponent to be a positive coefficient. Okay, look at x squared right now. Is it positive or negative? Right now it's negative. Okay, if I send it to the other side, it can be positive. So that's what I'm going to do. I'm going to send everything left. So I'm going to take those two x's and I'm going to add them to the other side. I'm also going to take those two x squareds and I'm going to add them to the other side. Okay, and then see what that gives me. Okay, the two x's cancel. The two x squareds cancel. That leaves 0 on the left. And on the right side, I've got two x squareds. I've got two x's. And I've got -5 constants. Okay. But again, if you want to bring them all left, that's fine. Okay. If you're just in the habit of you like everything to go left, it's okay. We'll get the same answer. Okay. All right. Let's see what our values are. A equals, B equals, C equals. What's A? 2, B, 2, C, -5. Very good. Hoping y'all are paying attention. All right, get the formula off the formula chart. X equals -b plus or minus square root of b squared minus 4ac divided by 2a. And guys, what you're going to find is that you work more and more and more with the quadratic formula, it gets a whole lot faster. Okay, it gets a whole lot faster. I'd be willing to bet, the first 2 questions on your assignment will take you just as long as the last 4 questions on your assignment will. You just get comfortable with it. It'll get easier. All right, let's plug in. X equals what? -2 plus or minus square root of what? 2 squared minus 4 times 2 times -5 over 2 times 2. There we go. X equals -2 plus or minus. What's under the radical? 4 minus 8 times negative 5, that's negative 40. So we've got 4 minus negative 40 over 4. X equals negative 2 plus or minus square root of 44. We're going to get an ugly number there. But at least it's real this time. We know it's real because we got a positive number underneath the radical. That's good. Our solutions are going to be on the x-axis this time. Okay. But since we can't simplify the radical out of there, we might as well just come to the calculator and go, help me out, calculator. I got negative 2 minus the square root of 44. That value needs to be divided by 4. And the calculator says we got an x value of negative 2.16. And then do it again. Numerator, I've got negative 2 plus square root of 44. And underneath that, we have to divide it by 4. The calculator says we got another x value of 1.16. And there you are. This parabola crosses the x-axis in those two locations. It's that simple. Okay, so hopefully that's a little bit of a review. I know it's been like 8 days since we did this, but that is what we did back before the 3-day holiday, before all the testing started. So that's what our assignment's going to be about. Okay, continuing to work with this equation. And then next week we'll start looking a little bit deeper into the quadratic formula and seeing what it is that it can actually tell us on some stuff. Okay, so